Hello, everyone. Thanks for joining. My name is Veer Muchandi. I am an application modernization solution manager. I work for Google. Topic for today, what makes a modern application platform? Since you are here, how many of you are either building or deploying modern applications today? Are you into building, deploying? Raise your hands. Yeah, most of you. Okay. If those who did not raise their hands, what do you do? Strategy. That's good. What else? Any other roles? Program management, project management. Okay. All right. So let's think about, even from strategy perspective, right? What we are talking about now is what are the enterprises looking at as they are looking into the future of what an application platform would look like. How do the applications run? Where do they run in the future? What should I keep in mind when I'm thinking about a newer platform to build modern applications? That's what we are looking at. That's the topic for today. The way in which I structured is I'll introduce you to the concepts of what a modern application platform would look like. Number two, I also show a demo of such a platform that actually does things that you'll be a bit surprised about on how it takes you to the newer world. We all know that the change is only constant. Those of you who are building applications, you are going through the change. How many years have you been making changes to your apps? All the time, right? So change is the only constant when it comes to applications, whether you are building or deploying it. Let's look at some of the types of changes that we are seeing in the industry today. We have corporate data centers, right? We have been trying to move those. Some of the applications are running in data centers provided by third parties. And there is cloud. That's another change, right? Apps could be running only on cloud, depending on what your business is. You could be just using cloud, or you could be using some third-party vendor's data center, or you could be running your own data center, right? But things are always changing on where you run your applications. One kind of change. The application architecture itself. You all know what monolithic applications are, right? Those huge, big bundled applications. And then we went into distributed architecture where we broke down those applications into multiple pieces. Each piece of an application runs on a different box, all comes together. We built those kind of things in the last 15 years or so. Last 5 years or so, people have been talking about building microservices. And now there are architectures which are even more lighter weight, which are called serverless functions and things like that. This is another kind of change that you would be hearing about. Makes sense, right? Another kind of change, process itself. Those of who, project managers, right? Waterfall, good old in one. We moved to iterative approaches with something like rational unified process in 90s. And then now we are agile, and now we are doing DevOps, GitOps, all kinds of changes in the way in which we are actually building applications and doing operations around them as well. Right? This is another kind of change. How are the applications actually packaged and deployed? So we used to package and deploy them on physical infrastructure at some point of time. Eventually, in early 2000s and up to 2010 or so, we virtualized the infrastructure and we started deploying applications on virtual infrastructure. Today, we are talking about packaging your applications as containers. How many of you know containers? Most of you, right? Yeah. So that says that, hey, this is the newer world with containers. In this context, what can we expect from, what do enterprises expect from a modern application platform with all those changes, keeping all those changes in mind, right? That's exactly what we are going to address in the architecture that I'm going to explain you. So enterprises are all over the place, as we discussed. You want to run your applications in your own data center, maybe on bare metal, maybe on virtualized infrastructure, mostly VMware, right? Maybe you want to run on cloud. which cloud, there are multiple choices there. You could be using GCP, AWS, Accenture, oh, sorry, Azure, and anywhere, right? Different places where you would want to run your applications. Now, one thing that you need to keep in mind when you are running in multiple places, if you want to move these applications around, right? Or if you want to run wherever you want, if you want to make your applications cloud native, then we need to have some common format, decide on some common lowest common denominator. And that is where containers come into play, right? So let's assume that any modern application that we build would be based, would be container based and Kubernetes based. So our Kubernetes will give you that abstraction to run your containerized applications where you want to run them, whether it is your own infrastructure, your enterprise data center, virtualized infrastructure, or on cloud, doesn't matter. But if you are using more than one of these environments, typically we have seen enterprises going to hybrid models. Maybe they are using their own resources in their data center, as well as they are using one of the clouds, like they may be running some workloads on GCP. And eventually they want to move everything to cloud. That's how people are thinking. But for a long time to come, the apps are going to run on both the infrastructures, right? Some people are even going for multiple clouds. If that's the case, you'll have multiple Kubernetes environments running in these different places. You have Kubernetes running within your data center. You have Kubernetes running on these clouds as well. So if you have multiple Kubernetes clusters, now we are talking about cluster proliferation, right? As opposed to what we were thinking about as virtual machine proliferation in the past, right? So you will have so many clusters running at different places. The operational concerns will translate to, hey, how do I manage this so many clusters and what is running on what? If there are issues, how do I troubleshoot? How do I deal with it, right? So the next step is centralized operations. So your modern application platform that has to run these applications, wherever you want to run them, needs to have a central place from which you can do the monitoring, logs, checking the logs. You don't want to get into each and every cluster and look at the logs there, right? You want to see them in one place so that there is one place where I can go and figure out what went wrong. Maybe your application that is built up of like maybe 50 microservices, and microservices could be running in 3 different clusters, who knows, right? Why do they run in multiple clusters? Because maybe your microservice 1 is running on GCP because it wants to use certain GCP provided services and this microservice should be closer to those services. So for example, if you like business intelligence, artificial intelligence provided by Google, then you would want to run those microservices that interact with those artificial intelligence applications on Google Cloud. Maybe there are some other services that you like from Amazon, the best of breed services provided by Amazon. Maybe you want to run certain other microservices on that cloud. Maybe there are some applications that have to stay within your data center, and those microservices might have to live within your own system. Now, your actual app may be composed of these multiple microservices coming together, right? But you don't want to get into each and every infrastructure to figure out what went wrong with this one application, right? And that's the reason why you need centralized monitoring, centralized log consolidation, ability to debug, ability to trace when things go wrong, alert management. Basically, you'll need a single pane of view across all the clusters where your applications are getting deployed. Do you all agree with me? Make sense? Yeah. Security. You can never say no to this, right? Security perspective. How do I do identity and access management? How do I pass the security context from one Kubernetes cluster to another? Because I'm talking about one app that is going across the boundary lines of different networks. Your own network within your data center and different cloud provider networks. You need to have security context passed across different boundaries for your application to run seamlessly across, right? Identity and access management is one of them. Second, how do I establish provenance of what is running. So for example, when you are building containerized applications, you know how containers are, right? They're in layers. You may get the operating system related packages from vendor one, maybe the middleware from vendor two, and then you are adding your own libraries on the top and maybe your own code on the top. But who is actually telling you that these are all safe to use? These libraries are safe to use. These operating system packages are safe to use. You need to establish the provenance of where these images are actually coming from, different layers are coming from, and somebody needs to sign and authorize and attest and say that, hey, these images are good to go. They are the right ones to run, right? So establishing image provenance, attestation, and only allowing approved images to run on your infrastructure is important. Establishing secure software supply chain, S3C is a term, right? S3C. How do I establish secure software supply chain? That's important. So that's again in the area of security. How do I have the right setup to do all that across these multiple environments? Policy management. I have certain rules that I don't want to run an application as a root, for example, anywhere across any cluster. I just want to apply that rule. I don't want to go and apply policy number 1 to cluster 1, policy number 1 to cluster 2, 3, 4 separately, and that becomes a nightmare. Can I just do it from a single place and it just gets broadcast to all and it starts getting managed across all the clusters in a GitOps kind of way? OPA is an open source project, open policy agent, that lets you do that. Define the policies in a centralized fashion and then apply across the multiple clusters of your choice, right? All these in the area of security and a lot more, actually. I'm just touching upon the points that you need to think about. This is where I'm taking you from, I don't know what I don't know to I know what I don't know kind of thing, situation, right? Did we think about all these things when are we thinking about all these things as you build a modern application platform? That's what I'm trying to get into your mind, right? Basically, what all needs to be thought through. Next. Your applications are deployed across multiple clusters in different locations. Some are in your data center. One of your same app is deployed in the US West region, US East region, maybe in Europe, maybe in Asia, and there are users all over the world. When a user accesses this application from, let's say, Japan, and if that request has to get served from US East, what does it, how does the response time look like, right? So, and you're talking about one application distributed across multiple locations. Can we redirect the traffic to the closest possible cluster so the user gets the best experience possible? That's where networking, global load balancing, and being able to redirect the traffic to the right location gets very important, right? Not just that, for some reason, if one of those clusters is down, let's say the US person is trying to access a cluster in US East. We are sitting right here and trying to access the application. It's supposed to go to US East, but the cluster is down. Can I actually, or it's overloaded? Can I actually direct the traffic to US Central or US West, wherever cycles are available, right? Can all that complex networking be seamlessly handled? That's where global load balancing comes into play. Makes sense? Next, how do I do traffic shaping? Now we are getting into real containerized cloud native applications. Yes, I am building microservices. Yes, I am building cloud native applications. But once we have this so many services running, hundreds and even typically thousands of services running, how do I do traffic shaping across these services? So let's say there is a service one version 1 got deployed and it is running in production, all nice. Version 2 just got available. Can I send some traffic as canary, make it a canary deployment and send a little bit of traffic there to test the waters to see how it is going? Can I eventually increase the amount of traffic going to that canary and eventually make that as the production version and remove version 1 out of picture? Or can I roll it back to version 1 if things don't go well? Can I, for example, allow a customer only X number of requests per hour or day or whatever, right? Can I do the rate limiting? So these kind of traffic shaping rules can be applied easily by an architecture that is provided by what we call as a service mesh. And Istio is an implementation of that service mesh. Istio is a open source project. It's an implementation of that service mesh. So when you are thinking about cloud native applications, you are also thinking about ability to support technologies like service mesh with Istio or others. Taking it to the next level. If you are trying to even do penny pinching on your infrastructure a little bit more and want to run your workloads only when you need them, and when you don't need them, they should go to sleep and not consume any resources. That's where serverless comes into play. Knative is a technology that allows you to do serverless applications irrespective of where the infrastructure is. It just needs a Kubernetes cluster. Right? So can you provide those options as well? Being able to do serverless, being able to do service mesh. Now, we touched upon this before. You would want to run your application workloads across multiple clouds or within your data center for a particular reason, because you want to use the best of breed services that are available in that particular location, right? You want to use artificial intelligence services from Google. That's why you are running your services at Google and be able to consume those AI services, for example. Or you want to access your private database within your data center, so you are running some of the applications within your data center. So how do I access those first-party services coming from Google, let's say? I need to be able to integrate directly from the platform without spending a lot of time on it, right? Or any other cloud provider. Can I just directly access those services provided by the vendors, or even third-party vendors, like other partners from the marketplace? Marketplace would have n number of different vendors who are publishing their applications. Can I just go and consume them? So I am building my own applications which are containerized, but I am going to integrate with other services that are coming from the cloud provider or third-party vendors. And those applications may or may not be containerized. It doesn't really matter. I just want to consume it. Make sense? So is it easy to integrate with all these? That's the next question, right? Now, once you have all this, if I am an application developer, now we talked about all the concerns of an operator to set up this platform. But now as an application developer, what do I need to build these applications on top of this kind of a platform? I need tooling. For example, if I want to write some code and test it, yes, of course, I can test it on my laptop or a desktop, but I want to test it in an actual real looking environment. So do I have integrations with tooling that I use today? For example, I use an IDE today, integrated development environment, like Eclipse, right? Or IntelliJ. I write my code in IntelliJ or Eclipse. Can I directly deploy into that platform and test it while I am writing my code? Right? Do I have integration tooling? Do I have command line tooling to talk to these different systems that are running in different places? DevOps, CI/CD. Do I have tooling for CI/CD? Do I have debugging tooling? Do I have test tooling? Do I have a registry to store the images? Do I have source control repositories? Right? So you need big set of tools that are needed by your application developers to be able to use this platform as well. Now, when you put all these things together, that makes up your modern application platform. Do you agree? Or do you agree? Yes, right? Yeah. So now with this in context, what are our choices? Do it yourself. Right? So when you're, you need to play with all those tools and technologies if you want to bring it all together, right? It's like putting all those Lego pieces together and figure out how it works. You have to test it, build that platform, and you also have to maintain it as well after that. It's not just one-time building, right? You need to keep everything up to date, maintain it, and all that. So There are advantages of do it yourself, that everything is in your control, but there are also disadvantages where you have to spend a lot of effort, time, and energy in order to maintain and manage this tooling, right? The other choice is go with a vendor built tool where you are vendor built platform where you're getting everything stitched together in advance. It's like a 3D printed module of platform. You just take it and start using it, right? So the advantages here are you get platform support from the vendor. You are getting best of breed technology knowledge and all good practices coming from the industry because the vendor has actually gone through all this and built it. And there are also free resources for core business, right? You can actually take the attention of your resources of your people and use them for the right thing, which is building your actually business applications, not spend time on the platform itself. Make sense? Okay. Now, what I'm showing you is an example of such a platform. Anthos, coming from Google, is that exact same an implementation of the modern application platform that I just explained you. All the things that when we put together in the previous figure is what makes up Anthos. So basically Anthos clusters, you can set it up on a cloud provider of your choice, whether it is Google Cloud or AWS or Azure, within your data center, on bare metal or vSphere, or you can get any Kubernetes clusters. It doesn't have to be Google provided Kubernetes. It can be any Kubernetes cluster and attach it as well. Okay. And then once you have these X number of Anthos clusters, whatever you choose, right? You don't have to run everywhere. You choose wherever you want to run, right? Once you have these clusters together, now we provide a multi-cluster management solution, which is Anthos, that has everything we talked about. It has Kubernetes API, which can talk to any cluster, right? You are not doing anything proprietary here. You're sticking onto Kubernetes. Service management Istio that we talked about. Now, from service management perspective, it's not just doing service management on an individual cluster. You can extend a service mesh across multiple clusters. Same service mesh running across multiple clusters. Not just that, you can also extend it to VMs, non-Kubernetes environments too, like VMs. Policy management. Remember we talked about OPA policy manager. So OPA is part of Anthos. Basically, the supported version of policy management comes from a tool called Anthos Config Manager, which includes OPA. The centralized operations, I'll show that in the demo. And you'll have a centralized management console from where you can look at all the clusters in one place and the application development tool. This is what Anthos is about. So basically, Anthos is an implementation of that. Now it's demo time. Any questions before I get to the demo? All good? Oh, yeah, good. On the demo? Yeah, I did have. Oh, are you talking about this one? Yes, and I mean, I didn't specifically mention that, but identity is also there in this. Yes, I can add that to the figure. Okay. Yes. Anthos is built based on all open source components. Anthos is more of supported thing coming from Google where we stitch all the open source components together. So for example, Kubernetes is open source, right? ACM is made up of the OPA policy manager, for example, that is open source. The GitOps methodology, Git repository is open source, for example. So everything is open source based APIs. Anthos service management, which is the service mesh thing, that is supported version of Istio. So every component of Anthos has open source behind it. Tools like, for example, management console and operations, those are already there in Google Cloud. So we are just using those same technologies. We didn't, it doesn't make sense for us to go back and then adopt open source for a console that already exists with Google Cloud. Does it make sense? All right, let's go to the demo. So what I'm going to show in this demo is multi-cluster ingress. What does this mean? We'll have, actually, I have a couple of GKE clusters. GKE is Google's Kubernetes. GKE clusters running on GCP, one in US Central, other is in US West. And there is a Anthos, the same Google Kubernetes cluster running on AWS. And that runs in Europe. So you have Kubernetes running in different clouds across different locations. Okay. And I'll show you a global load balancer that will be set up using this technology that we call as MultiCluster Ingress. What it does is, as the, I mean, you would have heard about Google's network, right? Google's point of presence is the best in class. It's there in every location in the world. So basically, when a traffic comes in from outside, from the point of your computer, from where you are hitting, till Google's point of presence, you are using regular internet. But from Google's point of presence to the actual cluster where it is running, that's all Google's network. And that's super fast. And we have SLAs that are committed around it, right? So what we will see here is, if the traffic is coming from, let's say, the US location, it goes to the US cluster, the nearest US cluster. If the traffic is coming from Europe location, it'll actually go to the Europe cluster, and you don't have to do anything about it. The global load balancer will handle it. I'm just showing one of the features that is key here and the most complex one to implement, but it comes so easily with Google, with this implementation. That's why I'm showing this example, right? So let me show you what I have. So this is that centralized console, Anthos centralized console on Google Cloud. You can see that there are 1, 2, 3, 4 clusters. Make it bigger. So these two are GKE clusters, Google Kubernetes Engine clusters. One is running in West, other is in Central. The other two are running on AWS. So while the clusters are showing up on Google Cloud Platform, the actual infrastructure is actually running on AWS. Okay, so the resources are coming from AWS, but the data is shown here. This is the management console for all of them. Now, there are workloads running on some of these clusters. I have workload running on West, Central, and the EU Central. These 3 clusters is the place where I deployed the same exact application. Okay, it's a simple app. The intent is not to show a fancy application or anything like that. Simple app, but show how the routing happens. Okay, so three locations I have deployed the same application, and there is a load balancer that gets set up with this MultiCluster Ingress. You see this global load balancer, and it has this IP address 34.149.95.78, port 80. Just one IP address across all the clusters. Okay, and it is connected to all the 3 clusters. Okay, now let's go to my desktop, and I'll access that IP address that I just showed you. You see where the connection went to? It went to US Central, because I have US West and US Central. Central is the most closest to this location. So the traffic went to US Central. Now, just to show that it can go anywhere I want, I can actually send the traffic to a different region. For example, if I want to force it to go to Europe, I can put it in the header and then force it to go to Europe. It will go there. Okay, so this is simple microservice, and it just outputs you where the traffic is coming from. It's just gives the metadata of where the traffic is coming from. That's it. That's the only thing it is doing. So this is being serviced by Europe's cluster, and the first request went to the central cluster because that was the nearest. Now let's do something. I have a virtual machine instance, and this is running in Europe West 3 region, right? And I'll SSH onto that virtual machine. And then let's run the same command from there. So basically, this is a virtual machine running in Europe, not in the US, although I'm accessing it from US. And from that virtual machine, I'm issuing the same command. Now it went to Europe instead of coming to US, right? So basically, the load balancer knows where the traffic is coming from, and it puts or it sends it to the right place so that the response is pretty fast for the end user. Make sense? Okay, now let's do something else. I'm going back to my machine, and there are a couple of scripts. Let's say one request, yeah, it goes to the right place. But what if there is a lot of load and the cluster is getting full, right? At that time, I don't want all the traffic. I mean, the cluster number 1 in US, for example, US West cluster to be used to be overworking, whereas the other 2 clusters are just running free, right? I don't want that. I want load to be distributed, right? So let's hit the global load balancer with lots of data, lots of traffic, and see how the traffic gets distributed. Okay. So what I'm doing now is I'm going to hit the cluster. So basically, you can see that there is a cluster 1. I'm defining that cluster 1 as West cluster and cluster 2 as the central cluster. Okay. I'm going to run a pod in the West cluster, in the cluster 1. Context is cluster 1. Okay. And I'm going to hit it at a rate of 20 requests per second. So 20 concurrent requests per second will go and hit that cluster. And let's see how the traffic gets shaped. So I'm going to run this command. By the way, and show something else. What you're seeing here is that monitoring console, the central monitoring console, and it shows you how the data is, how the traffic is flowing through. It's only one piece of the console. Okay. So the traffic here, you can see that since we are hitting the West cluster, it is since we are hitting the central cluster, then most of the traffic is going to the central cluster and very little is going to the other 2 clusters. The green line represents the Europe and the blue line, it's no backend selected. Okay, that's fine. Now the actual data is coming. There will be a little bit of delay between the monitoring system and the traffic that is flowing. So now the actual data is coming. We'll have to give it a minute. Most of the traffic is now going to the central cluster, and a little bit of traffic is going to the Europe cluster, and a little bit of traffic is going to the West cluster. So let's look at the numbers. Actually, that will make it easier. So 2,243 requests went to the West cluster, 55 requests to the central cluster when we are hitting at 20 requests per second, and 11 requests went to the central cluster. So basically, it is smart enough to know which one is the closest, and it tries to send more traffic there. But if it is getting overloaded, then it distributes the traffic to the other places as well. Right? Now let's change this a little bit. I'll stop this. And we'll hit it with 80 requests per second. We'll give it a couple of minutes to send a lot of traffic, and then we'll see how the distribution is. Any questions in the meanwhile? Yes, sir. It's called a global load balancer. It is one load balancer, and it cuts across the regions. Correct. No. No. Correct. So the platform Anthos comes with that multi-cluster ingress capability. And when you use the multi-cluster ingress, it's a Kubernetes resource. Just like any other Kubernetes application, you'll deploy multi-cluster ingress for your app. When you set it up, it goes and stands up a load balancer, and it does the networking across all your instances of applications running across different regions, and it can send the traffic to different places. Now, this is just one of the features of Anthos. This is not the only thing, right? I'm just showing you, I mean, with 45-minute thing, I can only demo certain things. There are lots of things that we discussed in that architecture, but I just chose this one to show. Yes, sir. Correct. So what I deployed is the cluster is Kubernetes cluster. It's not an EKS cluster, although you can do EKS cluster as well. What I deployed is Google Kubernetes engine running on GCP and Google providers Kubernetes on AWS as well. So it is Google provided software, Kubernetes software, running both on GCP as well as on AWS. But you can also do EKS cluster on AWS if you want, and connect that cluster to Anthos. That's also possible. Yeah. Yeah, I mean, I don't want to make this as a as a competition thing, but basically, you know who created Kubernetes, so that lies the answer. So. Correct. Right. Enterprises want certain, they have made some choices, right? They want to use, they have their own reasoning for whatever their choices are, but we respect that. But we are also providing more technology that makes your life easy. It's not just making a choice, it's also what you build on the top of it, right? And we are giving a pre-built platform to you, right? That's where this Anthos is coming from. Basically, forget about Anthos. The thing that we discussed before, all the components that you have to stitch together, right? You have to choose all those Lego pieces together and maintain it. That's the burden we are taking off with that vendor provided software, right? Let's measure it now. So you can see that 6,411 requests went to US West, 4,692 US, Europe, 986s to US Centrals, right? So basically, since the traffic is coming from US Central region, still most of the traffic goes there, but it gets more evenly distributed across other clusters too. As the load increases, the load balancer sends traffic to other regions as well. It balances the traffic across multiple regions. Make sense? So that was the end of my presentation. We have more questions. We have time. 6 more minutes. Yes. So we have Anthos on-prem and Anthos on bare metal, which runs within your data center. We have Anthos for AWS, Anthos for Azure, and we have GKE, which is running on Google Cloud platform. All the same Kubernetes. Yes. Yes, sir. So think about that as the next layer thing. You, as an application owner, your application may be made up of like 50 microservices. How should the traffic be shaped within your application between those 50 microservices is a choice that you have to make, and that you can make with your service mesh. Okay. However, there are maybe out of those 50, maybe you have 3 or 4 that are exposed to the outside world as APIs or UIs. Those are actually coming through the global load balancer. Make sense? The things that are coming from outside world, those are coming via the load balancer. The ones that are inside and you want to shape the traffic across different smaller microservices, that control, that fine, minute detail level control, you'll get through service mesh. Not just that, with service mesh, you can also do service to service security. You want the traffic to be encrypted between your microservices, do it with service mesh. It's not just traffic shaping. Correct. You can do certificate management between microservices. You can say, let's say you have 100 microservices. Think about how hard it is if you have to change the certificates, periodic rotation of certificates and things like that. Service mesh makes it super simple. So each have their own space on where they operate. Load balancer is at a higher level. Service mesh is at your app level. Yes, sir. Correct. So when you use the Anthos provided by Google, so when Anthos gets deployed on AWS or Azure, it collects the logs and pushes those logs and metrics to the centralized monitoring and logging system that is available on Google, so that all the logs and metrics are available in one place. You don't have to jump around places for that. Whereas if you were to use the EKS cluster, then you need to do some additional implementation there, right? With Anthos cluster running everywhere, it makes it super simple. Yes, sir. Good question. So in the world of Kubernetes, the firewall rules work a little different, right? So when you deploy your containerized applications, we're talking about Kubernetes here and containerized applications. Your containerized applications run as pods on the Kubernetes cluster, and those pods, placement of those pods on which node they go to will be decided by Kubernetes. I'm not talking about Google here. Any Kubernetes is the same. Okay. So let's say your app is running on your Kubernetes cluster as a pod, and it needs to talk to, let's say, a database running within your data center, let's say, or on a cloud provider, right? How do you know which particular IP address should be allowed to talk to your database on your firewall? It's hard, right? So there is no, because you have to open up your entire cluster through the firewall, because you know where the pod will get deployed, or at least a subset of the cluster where you're forcing the pod to reside. You cannot force it to reside only on one node, because that makes it like if the node fails, your app goes down, right? So for that, what we have in Anthos is an egress policy, using which if the traffic is going from particular set of nodes, you can set up that policy so that it goes with a particular IP address and the firewall allows it. So yes, that is all built in. However, again, the load balancer is at a different level. Your app's talking to your other services is at a different level. Now, between the load balancer and your application, if you want ingress policies to be applied, yes, you can apply them because we provide those tooling as well. Yes. Yeah, that is ingress policies. Yes. I was reading your question in two different levels, so I was answering both. Yes. Okay. I think we are up time. Any last question? All right. Oh, yes, sir. Sorry. Uh-huh. I'm not able to hear you. Yeah, you'll not get that parity because the features at the cloud level will be so different. So there are certain things that you cannot do because the technology is different. Yeah, you're right. Yeah. But regular Kubernetes is Kubernetes. I mean, if you take Kubernetes as your layer and think controlling on the top of it, yeah, those things will be the same. But under Kubernetes, if there are infrastructure specific things, there are certain things in which Google's technology is much better. So those features will not be available on AWS, right? So yeah. Thank you so much. Thanks for attending.